It is well known that Godwinning and Heidi Rohrer received the Nobel Prize for the invention of a scanning tunneling microscope, the first scanning probe microscope. But many don't know that the atomic force microscope, which is actually taking more than 90% of a commercial scanning probe microscope, was invented in Stanford University under the Professor Calvin Quate. At that time, Dr. Park was the graduate student. And he was really talented in instrumentation. So he built atomic force microscope in Stanford laboratory with Professor Calvin Quate. And when they reported the data and when they published the papers, people all around the world, like researchers, they requested him to build the same one in their laboratory. So at that time, he think that, okay, I think I should start the company. There was AFM companies, and like Vico actually bought all companies, original AFM manufacturers, and then in that way they monopolizing the market. So for over more than 10 years. And as a leader of the AFM manufacturer, I think they have a responsibility to innovate and develop a market. But at that time, I don't think they were successful in doing so. I think there's two factors. Actually, it gives us an opportunity to challenge the first position in the market. But secondly, we have to cope with the misconception of our customers who had bad experience in AFM. I think that was one of the most difficult part, to cope with the misconception and misunderstanding of this technology. Probably that's why last 10 years, the AFM market is not growing fast as we expected. It grows much slower than we expected. So, tapping mode for a tip, when you're close to the surface, there's a water layer always. Then it trapping it, these cantilevers. So they give much higher force or higher energy to do a tapping, to escape from the water trapping. So this way, they doing images. But at the first time, it was enough to give high resolution AFM images, but it doesn't give quantitative images, because when they touches it, it changes the probe shape. That means it will change the data with the times. So that's why we need to develop non-contact mode. So in that way, in order to make a non-contact mode, if we operate like a tapping mode, then it traps in the bottom. So we had to raise this cantilever much higher, and then give low energies, and then move much faster with the server, and then doing this way to do the non-contact mode. So technically, there is a second challenges in AFM manufacturing, because we are coping with the conventional measurement technologies like electron microscopy. It has much longer history than AFM, almost 80 years. So at the first time, it was also really difficult to use. But now there's with the technical advancement, now it becomes much easier. But for the AFM, another difficulty is ease of use. It's really hard to use. There's too much parameters to manipulate for AFM operation. It was really difficult to develop new algorithm for the AFM imaging, because we need to develop many many parameters to be automated. We need to sense these tip and surface interaction automatically, and automatically adjust this interaction force and translate it to our computer and server system to adjust maintain those distances, and then so people doesn't need to manipulate speed or set point, and all those things automatically adjusted by our new algorithms. That's another advancement. And another thing is that, so in research AFM, we developed this algorithm to make easier, but for the industrial customers, actually, for them, they don't want to operate AFM. They just want to use, press the buttons. So we need to make everything automated, like a transfer of samples, and replacing cantilever and focusing laser onto the cantilever, and making a set point. All those things has to be automated. I don't believe that AFM will not replace conventional measurement technologies, because AFM provide totally different way of looking on the surface. Before, a SEM or optical microscope, they are trying to see the surfaces, but AFM try to touch it and feel the surfaces. So it gives the additional touch to the conventional measurement. So in that way, AFM will become essential equipment to the research laboratory.